In this video, we're going to look at position function and what the derivative represents. So if you have a position function, the derivative actually represents the velocity, and we're going to show that in an example. So if I was given a position function, and most common in our book is one that starts with negative 16t squared. When you see negative 16, you know that you're working with feet and second, okay? Feet and seconds. If we were working in the metric system, you'd see a negative 4.9. But here we have, so I have s of t equals negative 16t squared plus 80t plus, I'm just making this up, 100. So let's say this is our position, okay? And what this is doing is that in reality, I'm standing on top of a 100-foot building or a cliff or something. This is my initial velocity, and this is gravity that's acting on it, bringing it down. So the idea here, if I drew a picture, is that we are standing here, right? I'm flinging something, and its position at every moment is going to be represented by this equation. Okay, now let's talk about the derivative. When I take the derivative, and I could do that pretty quickly using our rules, right? The derivative of this would be negative 32t plus 80. All right. Now what this is remember we were talking about rate of change. This is ds dt. The change in position per time. Well, that's velocity, guys. So this derivative is the velocity. Okay. Some important things to note is that what will happen is that the velocity is going to be positive as it's going up. When it hits the top, the velocity will be 0 because it's changing directions, and then on the way down, the velocity will be negative until it hits the ground. All right, so how this works is that if you wanted to know what is the velocity when it's at 1 second, all I would do is plug in 1 into this equation, and I think I get a positive 48. So I already know that at 1 second, it's somewhere over here. So over here, t is 1, it's traveling at a velocity of 48 feet per second. We could keep doing this. I could plug in 2, I could plug in 3, right? So if I plug in 3, I'm going to get a negative 16 feet per second. All right, so I know at 3 seconds, I'm on this side. And I'm not drawing it to scale, but I know that it's going to be on the downward side. As t is 3 is happening, I'm having a slope of negative 16 feet per second. The big question, of course, is how fast is it going when it hits the ground? Well, to know that, I need to know when does it hit the ground. So if it asks you what's the velocity when it hits the ground, the first thing I need to do is go back to this equation and figure out when does it hit it. Okay, so let me pause it for just a second as I clean it up. And we're back at it. So in order to find when it hits the ground, I want to set this equation equal to 0 because the ground would be a height of 0. And I'm going to solve this. Now, some of the book problems are factorable, but some are also not. So this is actually an example where this is not factorable. We're not going to get nice, pretty answers. You need to use the quadratic formula. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, now I've already taken a liberty to do some calculations. This square root is going to end up being 113.1, and the denominator will be a negative 32. And what's going to happen is you're going to get two answers. One answer is the negative 80 plus 113.1 divided by negative 32. And the other answer is a negative 80 minus 113.1 divided by negative 32. And what's going to happen is that this one's actually going to end up giving you a negative time. And this one's going to end up giving you a positive time. Okay, now the reason why you're getting a negative time and a positive time is because, let's go back to my picture. What it's doing is, remember the ground's here. So it's as if it went backwards in time and said, oh yeah, just so you know, this is happening like at negative 1. But this is happening at like 6. Okay, so I'm going to go ahead, and since it's super close to 1 and 6, I'm just going to round it to 6. Okay, so it's going to hit the ground at 6 seconds. So if you want to know the velocity, remember our velocity equation which by the way, you can always rename this v, the velocity equation was negative 32t plus 80. So when I put in positive 6, what I'm going to get out, and don't freak out, we know we're going to get a negative velocity because of direction. And it looks like I'm going to get a negative 112 feet per second. Okay. So good luck. The good news is that velocity, the derivatives are pretty fast. The trickiest part is when it asks questions like, when did it hit the ground? Because then you have to bust out the quadratic formula and then remember to go back to the velocity equation. So good luck. I hope it goes well.